Hello, everyone. My name is Kate Connelly, and welcome to my capstone project entitled Saving the Sea Lions One Click at a Time, using artificial intelligence to track stellar sea lion populations. For my capstone internship, I worked with the National Oceanic and Atmospheric Administration's Marine Mammal Lab, and I studied stellar sea lions and artificial intelligence. So let's dive right in. For a little bit of background, stellar sea lions are a species that live off the western coast of Alaska. There are two distinct populations of stellar sea lions, and the Western population has been on the endangered species list for decades. This means that under the Endangered Species Act, NOAA is responsible for keeping stock assessments of them each year, including population counts to ensure the well-being of the species. To do these population counts, NOAA scientists, like my site supervisors, go to Alaska each summer and take photos from small planes of all the different sites where these sea lions live, including rookeries, which are breeding sites, and haulouts, which are congregation sites where no breeding happens. Currently, these photos are then looked at when the scientists return back to Seattle, and each sea lion is counted by hand, a process that can take up to 9 months and requires at least 2 scientists looking at the images. Therefore, NOAA has been trying to implement an artificial intelligence software to increase the speed of this process. The goal is that the software would be able to take all of the images and detect each sea lion and correctly classify it in its proper age-sex class. So all of this information leads me to my research question. What is the detection and classification accuracy of NOAA's 2 potential artificial intelligence softwares? To answer this question, I spent my winter quarter working to assess one of the artificial intelligence softwares that have been provided to NOAA. The Marine Mammal Lab has a contract with Kitware, who has developed 3 different softwares for them to test, and I worked with the CFRNN software. I assessed the images from summer of 2021 at 8 different sites, rookeries, and haulouts. The figure right here in the middle, figure 2, is a great example of what I did day to day. On the left is an image with the detections made by the AI software. This is what I looked at to do my assessment. On the right is an image of a rookery with no detections, just to give you some context. The work I did, and I'm continuing to do, is to check the accuracy of these computer detections. I would look at each detection and determine if yes, it was a sea lion, or no, it was background, like water, rocks, puddles, kelp, etc. Then once I determined if it was a sea lion, I would have to classify it in its proper age-sex class. It was either a pup, a juvenile, a female, a subadult male, or a bull. I would input basic codes into the note area of the software to keep track of my quality control assessments, which were then all compiled for analysis purposes. I then compared the software that I worked on with the one my co-part Aria worked on to determine the accuracy and efficiency of each software. The 2 tables right here in the middle, center bottom, are summaries of my data analysis and highlight the most important points that I found. Listed are the percent accuracy for each age-sex class and the percent of misdetections for each age-sex class. So as you can see from these tables, both of the models were detecting sea lions with an average of 79% accuracy, highlighted in yellow. We also know that they were classifying age-sex classes with 93% accuracy. You can see that both models were detecting bulls, subadult males, and females within 95 to 99% accuracy. Pups were being detected with in the high 70s percentiles of accuracy. As pups are often missed or detected as rocks due to their small size and their dark brown color. We can also see that both models were only missing or not detecting an average of 3% per each age-sex class, which is also highlighted in yellow. The juveniles are highlighted red to draw attention to the poor accuracy rates, which are only around 26%. This is because reflections, kelp, or rocks all in the water are often misdetected as juveniles. Here in figure 3, you can see a juvenile in the water versus reflections in the water that the software is detecting as juveniles, just to give you some context there. Eventually, with all of my data analysis, it helped me to determine that it would be very beneficial for NOAA to implement AI in the stellar sea lion research group. As both software models were similar in detection and classification accuracy, which means that with a few more trial runs, either could be implemented in the workplace. AI is going to help NOAA save time and resources. The software can take thousands of images and detect the sea lions with 80% accuracy and classify them within 93% accuracy, all within seconds. Whereas when scientists do this work, it could take 6 to 9 months. And if these scientists aren't having to do this work, it will open them up to more conservation efforts and other projects. Finally, the implementation of AI for this project sets a precedent for many other projects within NOAA and other organizations. Conservation projects for right whales and polar bears are also starting to develop AI softwares on their own. There's an opportunity for so many other projects as well. Although the implementation is still in the trial and error phase, it is worth the time and effort that NOAA is putting in, because eventually it will help them save time and resources. But also because I do believe that AI has a place in the future of environmental science. I would like to thank my site supervisors for being so supportive and helpful, and for giving me the opportunity to continue to work with them post-grad. I cannot wait. The Enviro 492 crew, you guys keep me sane. And to my parents for allowing me the opportunity to attend UW and to be part of such a cool program like the POE. I would like to thank my friends for making the rainy months in Seattle more enjoyable, and for all the love. Thank you all for listening. Any questions?